Okay, this is Mrs. Downey, and we're going to move into, or wrap up 5.5 today, theorems about roots and polynomial equations. We're going to do the last problem set, turn it in, and then we're going to move on to 5.6. And we're going to work with graphing calculators, so I'll be passing those out while you're copying these notes. I'm going to give you 4 minutes, and then we'll begin. So when I give you a calculator, I'll give it to the front of the row and just pass them back. Oh, who needed tape? I'll get that in just a second. Oh, right here. Who needed tape for the poster? Who still didn't have a calculator? Yeah, see, the kids were just shoving them in at the end of the hour. Please, at the end of the hour, don't let me forget to take these out, okay? Because I checked out and make sure everything's good and put it correctly so they don't get broken. Does everybody have a calculator? When you finish, open up your, pull up your assignment. So when you finish this, open up to the, or turn your assignment over to the back. And I think it's problems 18, 20, and 22. See if you can work those now. I'll go over one before we start, but we're going to wrap this up very quickly. And you do them just like this. It's literally like a 15-second assignment. Excuse me?
What are we working on?
The back side of your assignment by 5. So turn your assignment over. 18, 20, and 22. And if you can't work them just yet, then just try to and sit tight. We'll go over it in about 16 seconds. Okay, if you'll turn your attention up here. Okay, so now you have this in your notes. This is on the test. Okay, now it's a lot of words for a very, very simple concept. It means if one of these are a root, if a plus radical b is a root of a polynomial function with a rational coefficient, then also a minus b is a root. And then for a polynomial function with real coefficients, if they have a complex root, such as a plus bi, then you know that also a minus bi is also a root. So let's look at what this looks like. So if I have, it says a quartic polynomial p of x has rational coefficients. If radical 2 and 1 plus I are roots of p of x equals 0, what are the other two roots? Well, just from that theorem, we just learned, well, that one, that's got the radical sign, so that's this one, the a plus radical b. So that means that we've got that, but our a is what? Just 0. So we've got 0 plus radical 2. Well, if that's a root, then also 0 minus radical 2 is a root. So we'll take off the 0. There's our first answer. Let's just identify the other two. So there's one of them. And then the other one, 1 plus I. Well, with the imaginary ones, the complex roots, if we've got 1 plus I, well, that is a plus bi. Right? Our b is just 1, so we've got 1 plus 1i. Then we know that 1 minus I is also the root. So that's all there is to it. So there's your two answers. Negative radical 2 and 1 minus I. So you're probably thinking, what did she just do? Let's look one more time. If this is a root, then this is a root. If this is a root, then this is a root. And there's the other two roots. That's your answer. Just flip the signs before the second term. But realize in this one, my first term was 0. So it's just negative radical 2. All right, any questions on that? Okay, now look at 18, 20, and 22 and work those very quickly, then we're going to turn them in. I'm going to give you 1 minute, right, because it shouldn't take long at all. You're just flipping signs. It should take you 5 seconds for each one. So I'm going to give you a minute, and if you're still stuck, oh, this one doesn't. There we go. This one's harder to start. There we go, 1 minute. If you still need help, raise your hand. Oops, be right there. Have your notes out. Any questions? All right, pass those forward. If you need an extra day, if you were gone yesterday, you can have an extra day, but don't get too far behind because the semester's ending. Okay. You may turn it in on Monday. I'm glad you're back. Glad you feel better. All right, pass those forward quickly. I'm going to pick them up. Thank you. Hopefully that was like a light bulb moment. Oh my goodness, that was so easy.
Yeah, those were here yesterday.
especially when you're on a field trip or a school function, you're always supposed to be making up your work, and that's not treated like sick work. You're still responsible for your work. Okay, so everybody has a graphing calculator. Now let's look at these answers real quick. So this one, what's the first other root? 1 minus 4i. And how about this one? Negative radical 3. And this one? Positive 8i. And this one? 7 plus I. And how about the bottom? Negative rad 2 and positive rad 13. I told you it was really a 15-second assignment. There's one of those on your test. So thank your lucky stars. That's easy, right? You got that. All right, so let's move on. And guys, I worked super hard to put these videos out online. I was up here till 10 o'clock last night, which is against everything I said I wouldn't do. But I called my husband and I said, I'm going to be up here late one night. I've got to get this laid out. What I did is I fixed things where we're going to get an extra day to review for your Chapter 5 test. And then we'll come back, take that test on the Monday of dead week. Then you've got your semester final. Right now you were getting 3 days, actually 2 days to review for your semester final, and then 1 day to go over it. So I stayed here and refinagled everything. That's why we're doing stuff quickly and turning it in. So stay with me, don't get behind, because after next Thursday there will be no makeup. So make sure that you're getting in here, like no one's coming before school. The 2 students who came yesterday took 1 quiz, and then just wanted help like I was the tutor. But remember, yesterday was Mr. Osborne was the tutor, right? I'm not the official tutor this year. So I opted out to let other teachers have that opportunity, okay? But I'm happy to help you, but that's before school, not after school. All right, now let's move forward. I said go straight to problem 2. Now we're moving into 5-6, the Fundamental Theorem of Algebra. So the objective is to use the Fundamental Theorem of Algebra to solve polynomial equations with complex solutions. Now, in the past we've learned the degree of a polynomial equation tells you how many roots the equation has. So if you look at, let's look at this bottom one right there. X squared, that means it's going to have 2 real zeros. Okay, now when you look at this x squared minus 4, where is it going? Because it's a minus 4, it's dropping down and it's hitting the x-axis at 2 points. That gives it 2 real zeros. Now this x squared minus 2x plus 1, when you graph it, it's only tapping that x-axis at 1 point. So there's 1 real zero. And if this one, in this case, you've got x squared plus 2x plus 2, that y-intercept is 2 and it's a positive parabola, it never hits the x-axis. So it has no real zero. Okay? Hitting the y-axis doesn't mean anything here. We're talking about hitting the x-axis. Okay? So don't get those confused. Now, hold on, let me clear that back off. Okay. So I'm going to introduce the Fundamental Theorem of Algebra. If p of x is a polynomial of degree n greater than or equal to 1, then p of x equals 0 has exactly n roots, including multiple and complex roots. So let's look at this. Oh, that's what we studied before. It says, what are all the roots of x to the 5th minus x to the 4th minus 3x cubed plus 3x squared minus 4x plus 4 equals 0. How many roots do we have here? Look at your leading, your highest term. Remember how to turn? You look at the highest degree of your polynomial. So that's a degree of 5. So we're going to have 5 roots. So look at the degree of your first leading polynomial. It will tell you how many roots you have. So this has 5. Now they're going to ask us, what are all the roots of an equation? Okay? And we've learned how to do synthetic division. We've learned how to do a reviewed polynomial division. And now we're going to learn how to use all this with the graphing calculator. So I think there was one thing I wanted to go. We're going to begin right here. So problem 2 of 5-6, and excuse me, there's one of these on your test, and the only one out of the section that's on your test, so that's all I'm going to go over right here. Finding all the zeros of a polynomial function. What are the solutions of f of x equals x to the 4th plus x cubed minus 7x squared minus 9x minus 18? So what we're going to do now is use a graphing calculator. Okay, so if you guys will get out your graphing calculator, I've got one too right here, and you want to turn it on and go to the main screen. I'll use this one. There we go. And you want to clear your memory, so remember second function, the plus sign, whoops, turn it on first, hello. Quit out of anything if you're inside it. Now go second function, memory, and then 7, 7, 1, 2. There you go. And you'll get the message that the RAM is cleared. Always start your calculator like that so you don't get intricately into a problem and then find out, I don't know, this is host up, I don't know what settings even did this, and so always clear it out. Now let's plug in, if we can get the graph of the equation, we can look at the graph and get pretty close to its zeros. We can also look at that leading term to decide how many zeros and roots we might have. But how do we get them exactly in rational terms? Okay? And so what we're going to do is learn how to put these in the graphing calculator and find our zeros. So we'll find the first zero with the calculator, and then we'll use our synthetic division to get it down to something we can just factor, a quadratic that we can factor, and finish it out. So this will help us get started. So once this is cleared, I want you to go up to your y equals. Now type in this equation, x to the 4th, and remember for powers, you use the, let me move this over. You use the caret symbol, the one that looks like a rooftop. So I'm going to go x to the 4th, and the x is to the right of the alpha key. So x caret 4 is x to the 4th, plus x cubed minus 7x squared. So again, there is a square button, but I like to use the caret sign to keep it consistent. Minus 9x minus 18. And press enter, and now hit your graph button. It's going to think, you're going to see the little rolling cursor till it finishes graphing. Well, a lot of this graph went off into orbit. It went off our page. Now we could do zoom functions and zoom fixtures, but really what are we focused on? We're focused on this x-axis, and we're focused on getting a starting point. And it looks like these lines are crossing right through -3 and +3, but we can't prove that. There are two ways we can prove it. We can calculate our zeros for this graph, for this side and that side, or we could also look at the table that's created by this graph. So let's do what we did last time. I showed you how to find zeros of a function, so let's do that first. So go to second function, calculate, and number 2 is to calculate the zeros of the function. Now it comes back and it says left bound. So we're going to take this left cursor. Let's see, right now x is on 0, so it means it's right here on this y-axis. So we want to move it over here to the left. So use your left arrow and start moving it. It looks like it's at 3, but let's prove it's there. Oop, I already passed it. So watch the x equal, and you want to get it right there, below that line, right here, below. Actually, left bound would be above it, excuse me. Let's go above it. All right, so when I clicked once above, it shot off the screen. That's okay. If you look right here at the numbers, it's still at negative 3.19. So it's really close, but it just shot off the screen. So press enter there. Now, right arrow over. Now we're underneath it to the right side of that parabola, and press enter again. And now, press enter. And it tells us this intersection, the 0, is at x equal negative 3. So it proved we were correct. It's at negative 3. So we've got one of our zeros. Now let's go prove the other one on the other side. So repeat the process. Second function, calculate 0. So number 2. And now mouse over to, let's see, left bound would be to the left side of this next intersection, which is underneath it. So, whoops, I went past it. Oh, I'm way past it. There we go. There it is. Okay, so right there, underneath it, and press enter. And now go above it. I'm just going to click it once because it went off the screen again, and press enter. And calculate, or guess. And it tells us my 0 is at x equal 3. So we were correct. It was at 3 perfectly, 3 and negative 3. Yeah, it might have calculated and said 3.2. But what we're looking for are the whole numbers. Now what we're going to do, because how many roots should we have? What was our leading power? 4. So we should have 4 roots. We have 2 of them. So now, put your calculator down, and now this is where we turn to polynomial or synthetic division. And we're going to divide out of this negative 3, and then we're going to factor out the 3 by using synthetic division. So when you get the negative 3 and you plug it in, and you do your synthetic division using 1, 1, minus 7, minus 9, minus 18, and that's what they've done for the first one right here, and you calculate that out, it's going to have a remainder of 0 because it was a factor, right? So whatever's left over here, now we've taken out the minus 3. What binomial did that negative 3 come from? X plus 3 equals 0 or x minus 3 equals 0? Which one did this come from? The x plus 3. So we know that x plus 3 is a definite factor of that. And our root that came from that is negative 3. Are you seeing how we're tying all this in with what we've done before now? When we found our zeros? Negative 3 is a 0, and we just proved it. Now, let's do this again. But now that we factored out that negative 3, now let's take what's left over, 1, negative 2, negative 1, negative 6, because it's still not at a quadratic, right? What is this? That's a constant, x power, x squared, x cubed. So we need to get it down to an x squared factor, so we have to do it one more time with our other root. So now we're going to take this, 1, negative 2, negative 1, 6, right there, and now we're going to divide out the other 0, 3. So what's left over should definitely be a quadratic. And when you do this, it is. Remainder of 0, it should be because it was a 0. We already proved that. So we've got negative 3 and 3 as 2 of our answers. Now what we're going to do is factor the quadratic with our factoring skills and get our last 2 roots. Right? Because we know the answer, we're going to have 4. So this is x squared plus x plus 2, right? Here, let me clear all this off. We know we've got negative 3 and 3. So we're looking for 2 more. Now, we've got, that's 1x squared plus 1x plus 2. Okay? And that's what they're showing. The beginning polynomial is equal to, excuse me, x plus 3 times x minus 3. We got that from the calculator, improving it. And what's left over? This right here, x squared plus x plus 2. But can we factor that using our factoring skills? What 2 factors of 2 add up to be 1? Nope, that doesn't work. So we're going to have to plug them into the quadratic equation. Quadratic formula. Oops, there it is. And so let's do that. So your A was equal to 1, B was equal to 1, and C is equal to 2. So when you plug it into the quadratic formula and you solve it, the last 2 roots come from there. So here it is. Negative 1 plus I radical 7 over 2, and negative 1 minus I radical 7 over 2. So there's your last 2 roots. So get your first roots, all that you can get, from your calculator. That gives you a starting point. Divide those from your original polynomial. Keep dividing it down and dividing it down till you get to a quadratic, an x squared term. Then factor it with your factoring skills or your quadratic formula and get your other terms. So there's all 4 terms. Negative 3, 3, and the 2 we got from the quadratic equation. That's all there is to it. By the Fundamental Theorem of Algebra, there are no other zeros, right? And so we knew there were 4 zeros, and we calculated all 4 zeros. Any questions? Okay, let's look at the, I think I'm going to work one more problem with you guys, so get your homework out for 5, 6. And look at number 8. 8 is started for us. If you're good with this, just start working 8, 10, 12, and 14. I'll take you through 8 if you're still unsure. Okay, so we're going to start off 8 by plugging it into the calculator. Oh, actually, look at your leading term. It's x cubed, so how many roots or zeros should I have? 3. So I'm looking for 3 answers. And they plugged it in, and it looks like there's only one that's perfectly on a grid. Right there. The other 2 are slightly off. So we're going to use only the whole numbers. So it looks like it's at 1. But plug it into your calculator and check it out. So let's do that. So go back to y equals, and just hit clear. You don't have to clear the whole RAM. Just clear your y equals. And now type in x cubed minus x squared minus 3x plus 3. Press enter and graph. So this time, instead of using my zeros, second function calculate zeros, I'm just going to go to the table. So go to second function and hit your graph. That's the table. And we know we're looking for where do these points cross the x-axis perfectly. So we're looking in this y column, right? And there's a 0 right there. The second one, there's a 0 in the y column. What is x when that y is 0? 1. So that's another way to find your zeros. Okay, so when y is 0, that's when it's crossing the x-axis, and it's a whole number 1. That's all we need, right? So that proves it for me. If you don't want to do it that way, you would have gone second function, calculate zeros, and then only choose the one that looks like it's perfectly there. So I'm going to go, ooh, this one would be hard to get. enter, and then, let's see, there, down at the bottom, enter, and enter. There it is. My 0 is at x equal 1. So we've proven one of our answers is 1. Now we need 2 more, which a quadratic would give us. So we like the x cubes. They're the easier, right? Than the x, there's less steps. So let's take this 1, and that 1, remember, it came from the binomial x minus 1. Okay? That's where that came from. Because what makes this equal to 0? When x is equal to 1. Now let's take this out of our polynomial. So we're going to have 1 in our box, and then it's going to be 1 minus 1 minus 3 plus 3.
Teachers, pardon the interruption. Students attending the transition fair with Mr. Estes, please meet in front of the main office at this time. Thank you.
So when you do your synthetic math, it goes, of course, it's what we expect, the remainder of 0. So now we're down to a quadratic. We've got x squared minus 3, because it's our x squared plus 0x minus 3. Well, the 0x we take out, so it's just x squared minus 3. Hey, well, we can just solve for that, right? Set it equal to 0. So what are we going to do? Add 3 to each side, and then take the cubic root of each side. So we get, whoops. What? Oh, I've messed that up. I'm sorry. Thank you. I meant x squared. I was like, when did we do a cubic? Okay, x squared equal 3. There we go. Now take the square root of each side, and you get x equal positive negative radical 3. Okay, so you've got a positive rad 3 and a negative rad 3, and there's your other 2 answers. Okay, so I worked 8 for you. Now try to work 10, 12, and 14 before you get out of here, and they're all equally that easy. Okay. Ten only has 3 roots, and 12 has 3 roots. We're doing 13, and there's 14. Okay, so work on those now, and I'll leave the first one up if that helps. But remember, first step is to put them in the graphing calculator to get a graph. Then do your synthetic division till you get a quadratic. Then just solve. So all of this stuff, it helps you get a starting point. And then we finish it off with synthetic division and solving quadratics. Hopefully all the stuff we've been doing is now you're starting to see the purpose of what we've been doing and learning this week. It's all coming together now. So I'm going to give you the rest of the class period to work this, and then I'm going to take them up. If I don't expect all 3 to be completed, I just want to see that you understand the process, okay? And then that will leave you with no homework this weekend. Yay! Enjoy that, because next week's going to get really hairy. Okay. And this concludes our lesson. I'm going to stop the video now. Thank you. Oh, yeah, that's right. That's it.